In our paper, we present a novel technique for groupware systems which takes time and latency into account. In the paper, we describe a number of examples which use this technique. The video shows 4 of these examples, which have been implemented using the Janus toolkit. Our first example shows an implementation of smooth corrections. In many multiplayer games, dead reckoning is used to predict the position of remote players. In the video, the blue square is using dead reckoning. When the direction changes, the square abruptly jumps to a new position. The red circle, however, is using smooth corrections, and when the direction changes, the circle just speeds up and smoothly moves towards the new location. Targeting and shooting. In multiplayer games involving targeting and shooting, the shooter must often estimate the amount of latency in the network and aim in front of the target in order to hit it. In the video, the light gray tank shows the amount the shooter must aim ahead of the green tank in order to hit it. Games, such as Half-Life, introduce the concept of lag compensation, which allows each player to see his own actions in real time and a lagged version of all remote players. This allows the shooter to aim directly at the target. The next example shows an implementation of telepointer trails. Showing a trail behind the position of a remote telepointer can be a useful feature in a shared application. Here we see an image being shared by 3 users. Trails are shown following the blue and the green telepointers. Our final example demonstrates catch-up following short-term disconnection. When a client is temporarily disconnected from a shared application and later reconnects, the simplest solution is to immediately display the current shared state of the application. An alternate scenario is to replay all the actions that have occurred while the client was disconnected. The actions can be replayed at a faster pace, allowing the client to see all the changes that occurred while he was disconnected, and be brought up to the current state as quickly as possible. Here, we see a simple drawing program being replayed at an accelerated pace.